today I've recorded a video for class since I will not be in school. So this is for Friday, October 2nd. So we're going to continue with composition, but this time we're going to take a graphic approach. So to get us started, we're going to do a quick review of this parabola. And on this parabola, we're going to talk about its domain and range. So we know the domain of f of x, which is our quadratic equation, is going to be all real numbers. But since this is bounded above, it has a restriction for its range. So it's any negative number since it opens down up to and including positive 4. For the g of x function, I'm going to arrow down a little bit. This function is absolute value. This function also has a domain of all real numbers, but it happens to be bounded below because it is opening up. So its range is closed at -3, open at infinity. Oftentimes when you're doing questions where you have composition of functions, because there's two different functions, you just really need to pay attention to exactly which graph you're working on. So when I see g, I know I'm going to the absolute value function. We'll do a quick little highlight to put those pieces together. So every time there's a g, that's the function I'm going to. And then for the f function, we're going to use our quadratic function for that particular piece. So question number 3 has us dealing with g of 3. So remember, function notation, which I'm just going to make a little note of right here. Okay, function notation is always going to be f of x. So that means the number that you're looking at in parentheses is the x value. So for g of 3, this is asking me what's happening to the function when x is 3. So I'm going to come to my g function, which again is absolute value. And I'm going to find where x equals 3, which happens to be right here on my graph at the point 3, -1. So this tells me when x is 3, my function has a value of -1. Let's do the same thing on the f function. This time we're dealing with what happens when x equals 4. So when x is 4, I find where it crosses on that little corner of the square. So this tells me I'm at the point 4, -5. So when x is 4, our function, or our y value, is -5. Okay, because remember, y equals f of x. In composition, like we did yesterday, we know that we work inside out. So first things first, we're going to go ahead and evaluate f of 3. So that means I'm using my quadratic function, and I'm looking for where x is 3. That gives me the point 3, 0. So if f of 3 is 0, that means I now need to evaluate g of 0, because I've used the piece from the f function, which now goes into the g function. So I come down to my absolute value graph. I find out what's going on at 0 for x. Looks like my answer is 1. So the combination is like a double substitution in order to get one single solution. I don't like the way the notation is for number 6, so I'm going to rewrite it so that it's f of g of 0. So this tells me inside out, I'm going to start with my g function where x is 0. That's exactly where we just were. So that gives me a y value of +1. So now I go to my f function, and I look for where x is 1, which is up here at the vertex, or the absolute extrema. And I find that when x is 1, y is 4. All right, next couple of questions. Let's see. Any values of x such that f of x equals 4? So I'm on my f function. Remember, f of x is a y value. So this is saying what happens when y equals 4. We just did that value, so I'm going to grab a highlighter with my yellow. And here's where y equals 4. Notice that it's touching the vertex of that function. and it's touching at the point 1 comma 4. So if I'm looking for my x value only, I know that that x value was at 1. Same idea for the g of x function, where g of x equals 5. What happens this time? First of all, you would tell me it fails the horizontal line test, so it's not a one-to-one function, but I could still answer the question. It looks like I have two possible places on my graph where my function equals 5. Looks like it happens when x equals 6 and when x equals negative 2. Is the inverse a function? So inverse we haven't talked much about yet, but it's coming. And so when we're dealing with inverse, we want to also make sure that we have an HLT that is going to be passed. So if I go to my f of x function, can I pass a horizontal line test? And our answer should be no, because when I do that, I hit the graph 2 times, which means that the inverse is not a function. So I'm going to say no, fails the horizontal line. Okay, next case. Use the table below to find the following composition. Same idea, instead of a picture, we have a table of values. So composition always starts inside out. So I'm going to find g of 4 first. So this says on the g, let's find where c4. So it's almost like you're going, okay, here's 4 on my g function. Where do they have to intersect? They intersect at 5. So now I need to do the same thing. I'm going to find 5 for my f function, which looks like v is going to intersect at 4. So this answer happens to be 4. Let's try that again. I'm going to change my color so you can follow what I'm doing. I'm going to try f of 4 first. So on my f function, I'm looking for where x is 4. So I do f function and 4 for x gives me a value of 2. And I take that 2 and I go to the g function. So 2 on my g function looks like my final answer gives me 3. So the final answer, if we use each of the question functions, is our solution. You can use the same function twice. So g of 4, we did that in letter A. So we did our g function at 4 gave us 5. And I'm going to do the g function of 5. So I do 5 over g, which happens to be 4. Okay? F of 4 gets a little messy if I keep writing on the graph. So this one I'm just going to talk about it. F of 4, so you can use your fingers. So from 4 on the left to the x that gets you a value of 2. And then f of 2 equals 1. The process continues. I'm going to have the position. So let's just follow this through. Remember, inside out first. So the f of 1 first. So 1 meter 3. Now we have f of g of 3. So 3 over to g equals 4. Now we have 4 to my f value gives me 2. So that would be my next table, kind of the same idea, but the notation looks a little bit harder. So they're saying a new function is defined by the composition. Whenever I see this type of composition, I always write it as g of x, and then here's my x value, which is happens to be 4. And as soon as I rewrite it, it's just like we did in the table at the top. We're going to do f of 4 first. So 4 goes to x, which gives us 2. Then we find g of 2. So 2 goes all the way over to our g function. That looks like g is less negative 3. To move letter b down here, so let's find the right. So for letter G, I have f of g of 1. Why don't you pause this, take a minute and try it yourself, and then check your answer. I go 1 over the g function, which happens to be 5. Then I take and substitute that into f. So 5 looks like negative 3. How'd you do? Letter C is reversing this. It's telling you the f of x answer has to be 4. So I'm going to use blue highlighter to do this. I need what f of x equals 4. So under the f of x, I'm looking for where I have a 4. Then I take that and I arrow over to the left, and I go ahead and I can see that happens to be when x equals 2. So that's just working your function in reverse. You can try the challenge if you want. If you think it's going to be too much, I'm okay if you skip it. Again, working inside out, you have to go backwards for the challenge. You have to use f of 4 first, and then use that value to find the g function that gives you enough. I'm going to let you try that one, then you can check back and see if you got it right. So if I do the challenge, I want to find the result to be 4 for f of x. It happens to work out with x is 2. Okay? So f of x equaling 4, helping when x is 2. So then I need the g of x function to result in a 2. Then the g of x function is a 2. That looks like it happens when x equals 4. So my final answer is 3. Last thing we're going to do is the composition system having both graphs on the same grid. I like the color coordinates for sure. So parabola is f of x, so that's my open function. I'm going to do all my x in blue things. And then g of x is the straight line, which is the red function. I'm going to do double my red. So if I'm doing f of course,